All right, today we're going to talk about two models and using these two models for some applications. First is the exponential growth or the unbounded growth model. And that is going to be represented by the algebraic function P of t equals P naught e to the kt. Okay, so this is our current amount of whatever we're talking about. Typically it's a financial model, so P would be principal, okay, right? So it'd be our balance in our account. P naught is the amount at time equals 0. So that's where that little 0 comes from. E is Euler's number. And Euler's number is a constant. It's 2.718, and I'll put ... because it keeps going forever and ever and ever. And we're going to use the E key on our calculator for that. T, of course, is time. And that could be in months, it could be in years, it could be in whatever is defined in the problem. And then K is our growth rate. K is our growth rate, okay? And it has to be positive. It has to be positive for it to be growth. Okay, K greater than 0 to be growth. If it is less than 0, if K is negative, we actually get decay. We get a loss, a lowering of the principal. Okay, so that's our first one. And this is anytime we have an unbounded exponential growth. That means that this thing can grow and grow and grow and grow and grow. A great example would be money in an account. There is no limit to how much that can grow. It's going to grow and grow and grow and grow and grow, okay? The second model we're going to talk about is called exponential growth with the bounded model, and that's also known as the limited growth or the logistic model, okay? And this is P of t equals L over 1 plus B e to the negative k t. Now, the big thing for anything we do with limited growth, you'll be given these constants. You'll be given, but k is our growth rate, t is still time, e is still Euler's number, L is the limit of the model. Okay, L is the limit of the model, and B is just a base. It's going to be a constant that's based on the problem at hand, but L is the limit of the model. Where we see this a lot would be an example of how many animals can live in an ecosystem. This cannot be unbounded because eventually the animals will run out of food. And so the food in an ecosystem would be a limiting factor. A simple example would be how many rabbits can live in a pen, okay? Rabbits can grow exponentially, but if you've got them in a pen, it's a limited growth model because there's only so many rabbits that can fit in a pen before they're literally standing on each other. And so that would be a limited growth model. And there'll be some clue in the problem to tell us which one to use, but if it's this one, we'll use this, and we'll have to be given most of these numbers, and vice versa, if it's this one, we'll be given this, and we'll have to know that it's most of these numbers, okay? So, with that, I'm going to switch over to some typed problems that I've got. So that's some problems that I've typed up that we're going to try, okay? So here's the first one. It says the number of patent applications N grew dramatically in recent years. Growth averaged about 5.8% per year. Assuming t equals 0 corresponds with 2009, when 483,000 patent applications were filed, find the function that would model this information. So here's what we're going to know. 483,000 patent applications were filed in 2009. So I know P0 is 483,000. Okay? Growth rate, 5.8%. So I know, I'll come up here and write it, K equals 0.058. Right? So we turn that percent into a decimal, 0.058. Okay, so if we take our model, if we say P of t equals P naught e to the kt, let's write our model. So our model would be P of t is equal to 483,000 times e to the 0.058 t. Now, this is known because it's a key on our calculator. It's Euler's number. It's a constant. This is known. So my only two unknowns are my current value and time. Okay? And if you think of an equation from algebra, you have x and you have y. Okay? You always have two unknowns in an equation. And so any kind of function or any kind of model. So we have two unknowns. So this is my model. This is my function for part 1. Now, it says to use this model to estimate the number of patents in 2020. So now, 2009, t equals 0. Okay? So 2010, t would be 1. 2011, t would be 2, etc., etc., etc. Okay? And so if we kind of, roll through this and think about it, what this is really saying is t equals 11. Okay, so we have two unknowns in our model, and they just told us to plug in t equals 11. So if I take my model, p of t equals 483,000 times e to the 0.058 times 11. Okay, that's what they want me to find out. And I'm going to take my calculator. It just turned off on me, actually. So I'm going to take my calculator here and try to position it so that we can see. And I want to show you, if you find your natural log button, above it will be your E key. So mine says E and a box. You say E to the X, E to the box, E to something, but it'll be an E key. It's always above your natural log LN button on your calculator. Okay, so I'm literally going to type this in. So I'm going to say 483,000 times, and since that's in yellow, I have to hit shift. So shift and then E. Now, my calculator automatically puts up a parentheses. Because I have to raise e to this entire exponent, if your calculator does not put a parentheses, you need to put that manually. 0.058 times 11. Close the parentheses, press enter. There's your answer, 914,170.095. Now, you can't issue a piece of a patent. So we're going to round this to the nearest whole number, and since that's a 0, we're going to round down, so it'd be 914,170. Okay, so P of 11, right, because T was 11, P of 11 is 914,170, 914,170. That would be our answer. Okay, now estimate the doubling time. Oh, oops. We should be using the letter N, not the letter P, right? Because the function is N. N is the number of patents, so it should be an N, not a P. But, again, just using the base model here. But it should be an N, since they told us that. Okay, so estimate the doubling time for N of T. So now, here's what we got to do, guys. What we're looking at is, go back to our original model. This guy is double this guy. Okay, and so here's where you have to get creative and just use numbers. Okay, you could use 5 and 10. You could use 100 and 200. Well, I'm going to be really lazy and use 2 equals 1 e to the 0.058 t. Now, basically what they've done, guys, is they've told us that this guy is 2 times whatever you put here. It's double whatever you put there. Okay, so I want to solve this. Now, how do I solve this? Well, basically, you're solving an exponential equation. So if you remember from algebra, we've got to get rid of an exponential expression. How do we get rid of exponential expressions? We get rid of exponential expressions with logarithms. And specifically, since this is base e, I'm going to take log base e of both sides. So I'm going to take the natural log of both sides. And my log properties will tell me that this becomes a multiplier, and the natural log of e is 1. So I end up with 0.058t. And the natural log of 2, I don't know. but I can type into my calculator, natural log of 2, and I write it down, 0.69314, yada, yada, yada. Okay, so I'm going to write that down, 0.69314, ... Now, we're going to divide by this. Okay, so if I take that same number still sitting on my calculator and I divide it by 0.058, right, because that's 0.058 times t, so we're going to divide, we get 11.95. Okay, t equals 11.95, or we would say roughly 12 years. Okay, it's 12 years to double. Okay, so every 12 years we would expect this patent applications to double every 12 years. Okay, cool. So let's try a different one. Interest on an investment is compounded continuously at 5.9% per year, and the balance P grows exponentially. Find a function that satisfies these conditions. So we're going to say P of t equals P naught e to the kt. Okay, so that's exponential unbounded growth. And what did they tell us? They told us that it was 5.9%. So this is going to be P of t equals P naught e to the 0.059t. Okay, that's it. That's our model. What do we have to know? We have to know the initial investment and the time. So it says, suppose your initial investment was $1,000. What will your balance be after 1 year and after 2 years? So let's do 1 year. This will be P of t equals 1,000 e to the 0.058 times 1. And if I type that in, 1,000 times e to the 0.058, and I'm going to skip the times 1 because 0.058 times 1 is 0.058. I get P of t equals $1,059.71. And we won't tell you where to round this because it's money. And so anytime you're dealing with money, it's going to be to the nearest penny. Okay, so we'll put our dollar sign there. Okay, so what about after 2 years? So 2 years. Same thing, right? We're going to say P of t is equal to 1,000 e to the 0.058. And this time we're going to multiply by 2. Okay, so P of t equals, and I'm going to type all this in. And this time I'm actually going to show you the results here. So I'm going to take this, I'm going to say 1,000, let's not do that. 1,000 times e to the 0.058 times 2. And make sure you've got that in parentheses, press enter, and they get 1122, and we get 995. Now that 5 is going to round up, which is going to add a penny to that. We add a penny to 99 cents, and you get $1. And so this will be 1123. This will be 1,123. Okay, so $1,123.00. Okay, so there we go. There's our answers to these questions, and that should say P of 2. P of 2. I haven't had enough coffee this morning, obviously. Okay, cool. So then it asks us the next question. It says, when will this $1,000 investment double? So our model becomes this. 2,000 equals 1,000 e to the 0.058 t. Right? So we started with 1,000. Double would be 2,000. And they want us to solve this. And what I'm going to do, guys, I'm going to use a 2-color code here. I'm going to actually do my work to the problem in red. Okay? So the first thing I'm going to do is divide by 1,000. Why? Because it says 1,000 times e to the whatever. Okay? So divide by 1,000. Now, lucky me, and you're going to see this kind of happened on the last problem we did. This is going to end up with 2 equals e to the 0.058 t. Now, same thing. I want to get rid of e. This is an exponential function. To get rid of an exponential function, we use logarithms. This is an e, so we're going to take log base e of both sides. Okay? log base E of both sides. Now, log properties, this guy becomes a multiplier, and log E, natural log of E, is 1. And so I get 0.058t. And the natural log of 2, I did it earlier, but I don't remember it, so I'm going to do it again. 0.693147 ... Okay? And then what? We're going to divide by 0.058. Okay? So we're going to divide by 0.058, and we get 11. It should be about the same because it's about the same numbers before. 11.95, and there's more, yada, yada, yada. And so, again, we would say that the doubling time is about 12 years. Okay, about 12 years. And if they ask for 1 or 2 or 3 decimal places, we would round it appropriately based on their information. Okay? All right, so let's do another one. A bank says that your continuously compounded investment will double in 15 years. What is the interest rate? Okay, so here's what we've got. We've got P equals P naught e to the KT. And here's what they've told us. They've told us that whatever we invest will double in 15 years. That's what they've told us. Whatever we invest will double in 15 years. So the only unknown here is K, which is our growth rate. And that's what they want us to find. So what do we have to do? Well, the first thing you would do is divide by 1, if you so choose, to get this expression by itself. I'm not going to do that because it's not going to change the problem. How do we get rid of this exponential expression? We're going to take the natural log of both sides, right? Natural log, and we get 0.693147 and all that jazz is equal to what? 15K, right? Because the natural log of E is 1, and this exponent comes down as a multiplier, okay? So we get that. Now what? Divide by 15, right? So divide by 15. Divide by 15. And so I get K equals, and let me do some typing here. So natural log of 2 divided by 15. No, that's not right. Try that again. Natural log of 2. Yeah, divided by 15. Okay, there we go. That works. All right, 0.04629 ... Okay, and how far we go will be determined by whoever's asking this question. We don't really care about that. You know how to round. Typically, these will be, 3 decimal places. Pretty typical. Okay, so K would be what? K equals 0.046. Okay, now, here's the problem. That's not your answer. Why? Because interest rates are percents. Okay, and so your interest rate would be 4.6%. Okay, so we're going to turn this decimal, right, 1, 2, into percent. So make sure you move your decimal, turn it to 4.6%. Okay, so anyway, we're going to stop there, and we'll pick up and do the second half of this as a second video. If you have questions, leave them in the comments, and I'll be glad to answer them.